Hello my dear student friends, welcome to my YouTube channel KK's Maths Academy. I hope all are doing well. I guess all of you are watching my videos completely and subscribe my YouTube channel KK's Maths Academy. Already I discussed in previous video a link with introduction of complex number and different forms of complex numbers. Today I am going to teach complex numbers only, but good important concept link with cube roots of unity. Link with the cube roots of unity, important concept regarding our JEE mains and advanced examination point of view. Important concept link with our complex number for today discussion. For today video completely link with the complex numbers only. So your concentration required, don't deviate from the class, don't fear about the subject. If you watch all videos in complex numbers, definitely my student become a master in complex number. Don't worry about that, I am here. Now, in last video, different forms of complex numbers given. Different forms of complex numbers. Here, I think you know very well, if you observe, if you watch last video, definitely you have an idea of 10 forms given. 10 forms, simple views, simple view or simple introduction about all 10 forms I am going to give, and then I will continue the today video topic link with cube roots of unity concept. Most important concept in our complex numbers chapter. More weightage, more focused topic, more focused concept. Cube roots of unity. You know very well about omega square, a special symbols. They are connected with a special symbol I. Okay. Don't worry about what is I. Don't worry about what is omega square. Okay. So our today discussion confined to cube roots of unity concept, complex number in cube roots of unity format or cube roots of unity representation. Complex number in cube roots of unity representation. That is our today discussion. Before I enter into our today discussion, a simple, okay, the last video, some balance, I am going to give the balance explanation for the forms given. Don't deviate and concentrate. Here, 10 forms given in last video, introduction of complex number video. If not watch, my dear beloved student, please watch previous video also, then it will be a continuation this video. I think you understood my point. Okay. No confusion. There is a clarity in confusion also. If you feel comfort while watching videos in serial order. Serial order means first complex number introduction, different forms given in last video. Now I am going to give clarity about the forms. I think first form given is a purely real form. Purely real form. Suppose a complex number can be expressed as x plus iy, purely real means concentrate, y equal to 0. Here x is called a real part of z and y is called imaginary part of z. I think you understood my point. In generally, complex numbers denoted by letter or represented by letter z as x plus iy. Some others denoted by letter c also, no problem. According to your convenience, you have to use. But in generally, majority Don't confuse with the letter Z as integers. It is not integer. It is a complex number representation as a Z. Z means a correct. Z means complex number. An expression in the form x plus iy form is called a complex number. Here, suppose if it is Z, it is also named as Cartesian, rectangular Cartesian form of complex number. But now I am going to define purely real means imaginary part is 0. Imaginary part is 0. Here, x is called real part of Z, y is called imaginary part of Z. Now, imaginary part of Z 0 means y 0. Here, y 0 means it is called purely real. Purely real means, my dear beloved student, clarity required. Purely real means imaginary part is 0. I think you understood. Purely real. Purely real means it is imaginary part is 0. Second one, imaginary number. Imaginary number means imaginary form. Better, imaginary number means only a link with I is called imaginary number. Okay. So our form is imaginary form. First one is purely real form. It is imaginary form. Imaginary form means here real part, here imaginary part. Imaginary part not equal to 0 is called imaginary form. I think there is a clarity after this form. Purely imaginary. Purely imaginary form. So concentration required. Purely imaginary means real part 0. So x equal to 0. Now coming to first, second, again third. First means it is purely real. Purely real form. Okay. Purely real form means what? Purely real form means imaginary part 0 means y 0. I think clarity required for all three forms that are there on video, on this picture. Purely real form, purely real form, y equal to 0. Purely imaginary, x equal to 0. Y not equal to 0, y not equal to 0, it is called imaginary form. So there is a clarity about all three forms of basic forms of complex numbers. Now I am entering into no order. According to my convenience, for my student understanding purpose, I divided into 10 forms. Nothing secrecy in dividing forms. Okay, fourth one. A rectangular Cartesian form. Already in definition itself it is there. Definition itself it is there. X plus iy is called a rectangular Cartesian form. I think you got my point. Rectangular Cartesian form. Okay, next one. Ordered pair form. Ordered pair form. Ordered pair means that rectangular Cartesian x plus iy represented as a ordered pair means it will be like a pair. This is x, this is y. Here x is a real part and y is imaginary part. X is real part and y is imaginary part. Means x comma y as ordered pair. This will be like a pair name called ordered pair form. I think you understood about ordered pair form. Ordered pair form. Next, cis form. Concentrate. Next, Euler's or Euler's form or exponent form. Clarity required about these forms because all forms according to the convenience, according to the situation we are using in applications. Euler's or exponent form. Cis form means cis theta. Indirectly cos theta plus I sin theta. The proof is different. Learning initial forms in a systematic manner is different. Okay, I think here for purely real, imaginary, purely real first, imaginary, purely imaginary, rectangular Cartesian 4, and fifth one is ordered pair, and the sixth one is cis and Euler's form, modulus amplitude form, mod amplitude form. Next, no order, no serial number. It will be our convenience. Try to understood. Vector form, logarithmic form. Here in logarithmic form, there is a simple introduction, simple formatting I am going to give. Exponent form or Euler form or Euler's form, a simple notation, e power I theta. It is cis theta, it is e power I theta. E power I theta also cos theta plus I sin theta, the simplification, but the notation is called exponent or Euler or Euler form. Here cis form cos theta plus I sin theta. Mod amplitude form, it will be like this. Concentrate here. Very important form used in the complex number throughout. R multiplied by cos theta plus I sin theta, where R is called modulus and theta is called amplitude or argument. Amplitude or name argument. In argument there may be a principal argument, general argument or amplitude. Vector form. Complex number can be represented as a vector. You know very well. This form is simply magnitude of vector multiplied by this amount of theta. This theta is called vectorial angle. Vectorial angle made by a vector or a ray with the positive direction of x-axis. The theta measured in anti-clockwise direction. Okay, there is a discussion in detail if in applications, don't worry about that. But as a teacher, I want to introduce in a smooth way the format, so that's why it is given for clarity. This is magnitude of a vector, and this theta is the vectorial angle. That angle, vectorial angle means the ray making an angle theta with the positive direction of x-axis in anti-clockwise direction. Logarithmic form. Even in logarithmic form, log form also, right, there is a clarity, log form also. By taking principal value into consideration, by general value into the consideration. In generally, log of x plus iy as 1 by 2 multiplied by log of x, 1 by 2 multiplied by log of x square plus y square plus I tan inverse y by x, by taking principal value into the account. If you take general value, this will be 2n pi I plus of log of x square plus y square plus I tan inverse y by x. Okay, in detail discussion about the form, if we enter into the individual concepts in our important weightage topic, not only in algebra, generally mentioned in unit like quadratic equations and complex numbers as a unit for our according to the stream given, syllabus given. Okay, I think all 10 forms given. It is the principal value. By taking principal value, this is the form. By taking general value, this is the form. So my dear student, I think there is a full clarity about all 10 forms introduced in first video, means basics of complex numbers. In last video, about the 10 forms given. Now this is a simple introduction about the format or representation. It may be analytical or it may be graphical according to the form. So here up to this moment only 10 forms in last video regarding complex numbers given. In complex numbers, now I am going to introduce important symbols, don't think it is a w and a w square. It will be called as omega. Omega. This will be omega. That will be omega square. This will be omega square. A special introduced symbols in particularly cube roots of unity, most important concept in our complex numbers chapter. Be cautious. Here, you know very well, roots of concentration required, don't deviate. The chapter is very simple. If you concentrate in our discussion, if you participate with me, with a good interaction between you and me, so don't deviate. Suppose, simple example, roots of x square minus 1 equal to 0. From lower class onwards, you know the method. The root means the value satisfied by the equation. Here, if you observe factorization, so here roots are minus 1 and plus 1. You know very well. Correct? Okay. In real system, it is possible. So the roots agreed as plus 1 and minus 1. Suppose our question, roots of x square plus 1 equal to 0. Now, in real system, it is not possible. Now, that's why imaginary number comes into the picture here. If you concentrate, imaginary number here, because x square always positive, or it may be 0, but never be negative. So, it is always positive, or there is a chance of 0. If it x 0, 0 square 0, 0 plus 1 never be equal to 0. So, in real system, no solution. In real system, in real number system, no solution. So that's why invention of another imaginary number by the great Euler invented the letter I, introduced, is called iota, imaginary unit, not positive, not negative, not 0. It is not in real system. It is only in imaginary unit, imaginary system. In complex numbers only, it will be developed like I as root minus 1. The proof of I as root minus 1 also will discuss in future videos with the vector method, with the similar triangle approach. There will be a clarity about why I equal to root minus 1. Don't worry about that. But at this moment, so cautious about the notation I equal to root minus 1. But in detail, we'll discuss in coming videos the reason for I as root minus 1 imaginary unit. Okay, it's not in real system. Means x square as minus 1, x square. So I introduced as minus 1. So by all integral powers, I square as minus 1. So this will be I square as minus 1. So x equal to plus or minus I. So if you take x as I, if x as I in the parent equation, I square minus 1 plus 1, 0, it is satisfied. Therefore, I is the root of this equation. So I is defined as root of this equation. Even minus I also, if you substitute here, minus I whole square, it will be plus I square, because minus whole square even power, it will be like this, it will be 0. Therefore, I from now onwards, a imaginary unit, a Euler's unit, root of this equation. Correct or not? Okay. I think you understood about I. Okay. I known as iota as root minus 1, I square as minus 1. Now concentrate. A simple theory now I am going to give, because all majority of the students know about the roots of this means definitely you go by, you or me go by minus b plus or minus root of b square minus 4ac by 2a. Correct? Roots of the quadratic equation in generally ax square plus bx plus c equal to 0. Roots of that quadratic equation, if you observe, roots of quadratic equation, if you observe, alpha beta alpha, beta is a formula minus b plus r into root of b square minus 4ac by 2a. Right? Correct or not? Okay, you know very well. Now if you observe here, if you pick up discriminant first, discriminant, what happens, it will be b square minus 4ac value, b square is 1 minus 4ac, so it will be 1 minus 4 minus 3 negative, so the discriminant is negative. What is the nature of roots of the equation? You know very well. Roots imaginary. From lower classes onwards, you know very well. Discriminant less than 0, roots are imaginary. So don't deviate from the video. Your attention required. If you, my student with good interest, my interest will be square, or my interest will be cube, or my interest will be power 4, means my concentration also will be increased. If you watch video without any deviation, definitely it will, with a good interaction. Today I am going to cover few examples based on cube roots of unity. Now I am going to introduce what is omega, what is cubed root. Please wait. Here roots imaginary because discriminant less than 0. Now you understood? Okay. It is clear. With our discussion only, with a good interaction only, the nature of the value or the symbol of discriminant is less than 0, negative. So roots are imaginary. Okay. Roots are imaginary. Imaginary means not seen with the naked eye. It is, seems to be imaginary, not real. We say word imaginary. Imaginary. So here x equal to minus b plus or minus root of b square minus 4ac by 2a. I think by the formula, in general formula. So minus 1 plus or minus root of minus 3 by 2. Right, concentrate. Minus 1 plus or minus 3 into minus 1. Here I think it will be very simple discussion. I square, I as root minus 1, I square as minus 1 by 2. So here minus 1 plus or minus I square I and root 3 by 2. So here roots of from simple low level, basic level to the high level, already I told in first video, simple to superior level, 0 to high level. Means, so that's why my more focus today on basic level of I and basic level of introducing I and omega. So don't think it is a time waste. It will be essential in initial stage for my student, because my student is my energy for my supporters. So please subscribe my YouTube channel KK's Maths Academy and watch video completely. Okay. So here, if you take plus here, minus 1 plus I root 3 by 2. If you take minus, another possibility, so minus 1 minus I root 3 by 2. So therefore, from now onwards, roots of this equation obtained are this. Means minus 1 plus I root 3 by 2 minus 1 minus I root 3 by 2. You understood? So here the great experts represented as the letter, this as omega, this as omega square. One special connection. One is a reciprocal of the other. One is a reciprocal of other. Means concentrate. I think you understood my point. There are two standard results linked with omega and omega square. This will be given like a representation. I as root minus 1, root of x square plus 1 equal to 0, already discussed in previous example with our discussion. It is completed. Now it will be a roots of this equation, a quadratic it is, like this format. Now roots are represented as omega square. There are two standard results with this, these two. Concentrate. Don't deviate. 1 plus omega square 0, omega cube is 1. Two important standard results linked with this cube roots of unity. Here, okay, not cube roots of unity. Here, these are the standard results based on this. Now I am going to give the proof of 1 plus omega square 0, and also omega cube is what? 1. Don't worry. So omega, notation as minus 1 plus I root 3 by 2 omega square. If you take this as omega square, this as omega, no problem, because if you square 1, we get other. 1 omega is 1, if you square, we get other. Understood my point? Here there are 2, omega square. Concentrate. If I square first one, we get second one. If I square second one, we get first one. Concentrate. It will be omega power 4. It will be omega cube into omega. Please wait. A complete clarity given to you why it is 0, why it is 1, why it will be. It's a simple discussion. Concentrate. So omega cube has 1 from this standard result. So this will be. So you understood. Omega square are simply good observation. If you square 1, we get other. If you square 1, we get other. Means, if you square omega, we get omega square. If you square omega square, omega power 4 also omega by knowing omega cube as 1. And also 1 by omega square as omega. 1 by omega is omega square. Means 1 reciprocal of the other. 1 reciprocal of. If you cross multiply, it will be omega cube 1 by knowing this. Don't worry. Here multiply omega cube, and one more good observation linked with this roots of x square plus x plus 1 equal to 0. X square plus x plus 1 equal to 0. Roots are omega square. Then one more, a special link with the conjugate property. Right? Concentrate. What is the meaning of conjugate property? Conjugate property or conjugate complex number, right? Here x plus iy, conjugate is simply a z bar as x minus iy. The sum is if you add both, concentrate, if you add both, means z plus z bar is real. If you add both, iy cancel, adding 2x, it is real. If you multiply z into z bar, a plus b into a minus b, a plus b into a minus b, a square minus b square, already I square, I root minus 1, I square minus 1, it will be x square plus y square, also real. Means sum and product of two complex numbers real, means sum and product, then one is said to be the conjugate of the other. It is a simple analytical definition of conjugate complex number. Complex number is z and conjugate is z bar. It is the notation for conjugate, analytical notation. If you take graphical, so simply, very simple idea. Here x, y, but in our complex number system, the real axis, it is called real axis, concentrate. It is imaginary axis. Y-axis is imaginary, x-axis is real, and this will be origin reference point. Concentrate. Here z. Already I told a complex number represented as an ordered pair means a point in organed plane. Real part, imaginary part. So here complex number z can be represented as a point in the organed plane. Suppose if it is in the first quadrant, this is organed plane. P as x comma y means that P point is the simple notation for the complex number z. So z can be represented as a point P like ordered pair form. So here z bar is simply reflection or image. So P dash is x here, if you observe image reflection property means P dash is the image or reflection of this point P with respect to real axis. It will be x coordinate is positive, y coordinate is negative. Means according to the form of rectangular Cartesian form with the converting from the ordered pair form. So x plus iy is z and z bar is this one, this is a z bar, this is a z. So x minus iy in the fourth quadrant. I think image, you know very well about just simple conjugate here required. why I introduced this basic idea of conjugate complex number, the reason in my mind is only simple observation. Omega square already I introduced. Now only roots of x square plus x plus 1 equal to 0. But it is introduced. Now one important conjugate property while I am discussing, your conjugate of this is this. Very important conjugate property. Conjugate of this is this. Very simple. You know very well, omega minus 1 plus I root 3 by 2. If you separate real part, if you take real part separate and the imaginary part separate, if you take real part and if you take imaginary part separately, W, that is not W, it is omega. Concentrate. Omega is minus 1 plus I root 3 by 2. Here real part, and omega square is, we know very well, minus 1 minus I root 3 by 2. Here minus 1 plus I root 3 by 2, minus 1 minus I root 3 by 2. So omega square. So if you take separately, it will be like this. If you observe omega and omega square, both, if you take conjugate to this, it will be like this. Conjugate of omega, if you observe, this will be conjugate, means x plus iy conjugate x minus iy. Just now I introduced the conjugate. So conjugate of this means it will be minus, okay, understood, this will be minus, indirectly that is omega square. Therefore, omega conjugate is omega square. If you take conjugate of this, definitely we get the first one. So very important connections, it is given based on cube roots of unity. Not, okay, I am saying cube roots of unity, omega square. Now I enter into cube roots of unity, theoretical results, theoretical introduction regarding cube roots of unity. Right? Concentrate with the simple theoretical steps you can understood. Suppose let us assume cube root of 1. Now our target cube roots of unity, simple introduction, cube roots of unity, let us assume x. Right? Concentrate, don't deviate. Cubing on both sides. Very simple step. I am going to conclude. Cubing on both sides. Cubing on both sides, it will be x cube equal to 1, because if you observe the data 1 to the power 1 by 3 is x, it is the data given one, let us assumption first step as x. If you cubing on both sides, means it will be 1 power 1 by 3 cube means 1, it will be x means x cube, cubing equal to that. Now you understood this step. Immediately rearrangement, you are like this. You know very well algebraic formulae, a cube minus b cube, a minus b into a square plus ab plus a cube minus b cube, a cube minus b cube formulae. You know very well algebraic connection. I told from basic to high level. So this is simple introduction about till now not started any application, only theory, it is simply theory. A cube minus b cube as a minus b into a square plus ab plus b square. So here a is x, b is 1. So that's why it is. Now if you observe factors, a into b equal to 0. What it is? Tell me my dear student. A into b 0 means either a 0 and this is 0. So this will be x equal to 1. I think you understood. You understood. And for this x square plus x plus 1 equal to 0. So x equal to 1, it is a real because 1 is real. But already in previous discussion, for this quadratic equation, discriminant less than 0, roots obtained as omega square, already the discussion completed. So coming to our today concept linked with cube roots of unity, these are cube roots of unity or 1 omega square. I think now you understood about cube roots of unity or 1 omega square. Now very simple extension of this idea of cube roots of unity, many more properties already I discussed with cube roots of unity, like a reciprocal property, like a squaring property, like a conjugate property. Okay, my dear student, please wait. Very simple time I'm taking for proving these two results, because in applications I am going to use these two results. Be cautious. 1 plus omega minus 1 plus I root 3 by 2 omega square minus 1 minus I root 3 by 2. Now I am taking left hand side and I am checking it is 0 or not. Omega cube, as taking left hand side, I am going to prove as 1. Here, omega into omega square. You know very well, already we derived now only. First, theoretically, my student strong means it will be easily for solving JE mains or JE advanced or whatever it may be the objective question. I think you understood my intention. So please watch without any deviation. So omega square, denominator is 4. Okay. Now numerator a plus b into a minus b, a square minus b square. I think here I square as minus 1. So 1 minus minus I think plus 4 by 4 1. So very good result. Please keep in your pocket from now onwards. Omega cube equal to 1. Omega cube equal to 1. Now it is proved that result link with cube roots of unity or 1 omega square. Now one result omega cube is 1. Now this result, if you simplify, if you observe, okay, it will be like this. So here 1 minus 1 by 2 minus 1 by 2 minus 1, this plus and minus cancel, 1 minus 1 also 0. Okay, my dear beloved student, you understood. Cube roots of unity are 1 omega square, 1 omega square. Sum of these three roots is 0 and product of these three roots as simply 1. So sum of cube roots of unity 0, product of cube roots of unity 1. Based on these two results, applications are very simple, but the cube roots of unity, most popular repeated concept link with many sub ideas, link with determinant, concentrate, link with determinant, cube roots of unity link with determinant approach, cube roots of unity link with simplification, cube roots of unity link with sequence series calculation, cube roots of unity link with organed plane problems, link with geometry in finding area, in finding vertices, and cube roots of unity most popular in our complex number chapter to pick up minimum value, maximum value. Like this, till now not started any application. In next coming video I am going to cover cube roots of unity, only examples, good questions I am going to discuss. So please watch my all videos for complex numbers from roots level to high level. It will be elevated, and if you like my teaching, please subscribe my YouTube channel KK's Maths Academy. If you watch all videos, definitely my student becomes a master in complex number.